So today I'll be talking to you about my thesis, which is all about the risk and resilience of URM, which is basically unreinforced masonry buildings in New Zealand. So a masonry building is a brick or a stone building. And when you think about masonry buildings and earthquakes, what you can think about is like a Jenga tower. If somebody knocks your Jenga tower when you already have some pieces missing, so if a building's old, that Jenga tower is going to come falling down. And this is because masonry buildings were built before a lot of codes were implemented in New Zealand. So a new building that would be built up to today's code would be more like a Lego set where everything fits together, it all ties together really nicely. So when you bump the table, you still have a good like Jenga set going. So many of you will be familiar with the Canterbury earthquakes in 2010 and 2011. And this is a picture of the aftermath of the February 2011 earthquake. In this earthquake, 189 people were killed, and of those 189 people, 40 were killed by unreinforced masonry buildings. And this is a really big problem that my research is looking into. So what I've done most recently is look at a lot of pictures like this, like over 1,000 pictures of 600 different buildings, and what I was looking at in these pictures is where the debris has fallen. So you'll see, especially in this picture, a lot of that debris has fallen outside of the buildings, and this is different than most modern buildings like a concrete building, where what we're used to seeing is a pancake kind of collapse, where the building will collapse inward and the people most at risk are inside of the building. For a lot of the unreinforced masonry buildings in New Zealand, the biggest risk is to the people who are located outside of the buildings. So like I said, I've looked at a lot of these pictures and I've noted where the debris has fallen and whether that was inside or outside. And right now I'm in the process of developing vulnerability curves to kind of predict in a future earthquake, given the same sort of building conditions, where the building would fall and the people that would be at risk. So these are all going to be input into risk modeling software such as Riskape, if you're familiar with that. And in that case, building owners and like councils can see which areas are most at risk with the given building stock and prioritize where to put their resources to strengthen the buildings and make people more safe. And ideally, this would be applicable here in New Zealand and also back in my home of California, where we have really similar building stocks. Yeah, that's my research.